question 20.
Okay, let's take a look. Let me share my screen. From the book, right? I go back to the book.
Yeah.
Okay. 14, 16, 20. A box with an open top to be constructed from, okay. So, an open top, okay, let me start my, okay, I did start my new video. A box with an open top is to be constructed from a 4 feet by 3 feet rectangular piece of cardboard. Okay, so I have 4 by 3, and everything is in feet. Okay, perfect. Cutting out squares or rectangles from each of the 4 corners as shown in the figure and bending up the sides. So I have to copy this. So only one side is bent, I guess. Okay, so those corners, x, x, but the top corners, x twice x. Okay, I copied that. One of the longer sides of the box is to have a double layer. Okay, got it. Which is obtained by folding this. Okay. Find the largest volume that such a box can have. Okay. So, okay, so there is some sort of bend here, and so when we fold the box, okay, so the height, of the box on this side is x. I have to picture this. How is this done? So this is, I have to look at their picture one more time. Let's look at their picture one more time. Okay, so this is folded, but still the height is still x, right? It's just that it's doubled at one end, right? That's how I understand it. It's just folded twice in there. Okay, so I think I understand how it is. Let me see. So I think it's done like that. So this side has x by x. So this is x by x. No matter what I do, the height of the box will be x. Okay, so the height of the box will be x. It's just that on this side, it's folded like this. For some reason. Folded and up. Okay. So I think that, is this what you understand is happening?
I'm understanding the second fold to go on top, like as sort of a lid almost, maybe?
No, there is no lid.
Or like maybe the corners removed are like, in like it's weirdly folded and inserting it makes it steady and not need like adhesive of sorts, maybe?
No, the problem says that one of the longer sides of the box is to have a double layer of cardboard. They choose double protection for whatever reason they want.
So something like this.
Correct.
Okay. Good. So then the height of the box is still x everywhere. The length of the box will be 4 minus 2x. But the width of the box will be 3 minus 3x. So this is 4, but when I take out those two x's, this will be 4 minus 2x. And here on the width is 3. Sorry, the width is 3. But I have to subtract 2x and x. Yep, got it. Good. So then the volume, let me go back for 1 second. Okay, we figured that out. Find the largest volume that such a box can have. Good. So we want to maximize the volume. That's all they want. Okay, perfect. So then the volume of this box will be base times height times width. Width times base times height, height times width times base, it doesn't matter. So this is the base, the width, the length. I don't want to write base, you know what I mean, length. So 4 minus 2x is the length, width 3 minus 3x, and the height is x. I'm going to multiply these two first. So I get 12 minus 12x minus 6x plus 6x squared, and then multiply by x. 6x squared times x, negative 18 x squared and plus 12x. So it was just impressive to find, to play with my little box, but the rest is just a polynomial function. So v prime of x is 18x squared minus 36x plus 2, and I have to set this equal to 0. I will divide by 2, 9x squared minus 13x plus 1 equals 0. I'm dividing by 2, 18x, not by 3. So 9.
Professor, isn't this supposed to be a 12x?
Here?
No, the 2x. Because up above you distribute 12 to x, right?
Yeah, that's supposed to be 12x.
Oh, here. Thank you, from here. Yes, 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 yes. Thank you, thank you, thank you. Thank you very much. Okay, so it's 6. Thank you. So one more time, I'll divide by 2. 9, 18, 6. Okay, so now I have to find solutions with this. Yes, I don't want to use the quadratic formula because I have my calculator. So I have 9, negative 18, and 6. Just give me solutions. Come on. Good, got it. So x equals 1.58 approximately, and x approximately 0.42. Okay. I don't think that this is possible. Sorry?
You show me how you plug that in your calculator?
Only if you have TI-86.
You can do it on the TI-84.
Yes, you can. Just use the quadratic formula also. Same thing. Negative b plus or minus the square root of b squared minus 4ac. 4 times 9 times 6 divided by 18. Okay, so now we have to make a decision about x, which is the height. So if x is 1.58, then this distance becomes negative. That's not possible. So this is the only possibility, and this is in feet, that the height is 0.42, and that will give the maximum volume. Who cares? I have to show you that this is the maximum volume, right? We don't trust this before we study the sign. So this is x at 0.42. So this is v prime of x, and this is v of x. So, where is it? Okay, right here. So between solutions will be negative. So here is, between those two would be negative, so this is positive. So this is typical for a maximum, because the other one will be here. at 1.58, but not possible. So this is guaranteed to give a maximum volume. What is the maximum volume? I have to find out. So if I want to find out V of 0.42, I will 6 times 0.42 to the third power minus 18 times 0.42 squared and plus 12 times 0.42. Oh, that's what when you don't look. 0.42 to the third power. Okay, minus 18 times 0.42 squared plus 12 times 0.42. What did I get? 2.31 approximately. Of course, cubic feet. Now, we also have to determine the length and the width. So we only determined x, that is 0.42 feet, and length and width. Okay, so 4 minus 2 times 0.42, and 3 minus 3 times 0.42. So the width, 1.74 feet and 3.16 feet. No, before you ask, no, I don't want you to spend half an hour on a test. I want you to spend less. So, on each problem, of course. However, very good problems you chose. Anything else?
I have a question.
Yes.
On this problem.
Yes.
How'd you know to throw out 1.58? Yeah, how did you know that we couldn't use that number?
Okay, so let's try. 3 minus
never mind.
3 times
That's not
1.58. I get that the width is negative 1.74 feet.
Okay, I got you now. Thank you.
Thank you. Good. Next question. Anything else you would like to go to?
I was hoping we could do one from the homework that was due today.
Yes, anything.
The law of intelligence rules, problems.
Yes,
It was in
anything.
Chapter 4, question 48. And it was from the book. And
You mean this is in 4.5? Is it in 4.5?
4.4.
Okay, sorry. And the problem is number
48.
48. So let's take a look. Let me share my screen. Oh,
From 4.4.
I know. Mark said it twice, 4.4, and in my mind it was still 4.5. Sorry about that. 48. Very good. Excellent. So let me copy it and I'll stop sharing. So limit as x approaches infinity, x to 3/2, sine 1 over x. Okay. So obviously this approaches infinity, and this is a problem, right? In the sense that, you know, first, I shouldn't say a problem. So it's x approaches infinity, this will approach 0, and this will approach 0. Okay? So basically this is infinity times 0 or 0 times infinity, which is the same thing. So if you remember when we talked about the indeterminate cases, we said that this one is not too bad. There are others that are worse, the powers. But this one is not too bad, as long as I can manipulate the function. You could keep this here and then just rewrite sine using cosecant. Or I can leave alone sine at the top and reverse this here to x to negative 3/2. because x to negative 3 halves is the same with 1 over x to negative 3 halves is the same with x to 3 halves. Let's see what happens. So the top is still 0, and now the denominator is 1 over, right? So this is the same with 1 over x to 3 halves. So when the denominator approaches infinity, 1 over infinity will be 0. So I'm happy with this because I can use L'Hopital's rule. So always remember, 0 times infinity should not be a big problem. We should be able to manipulate it algebraically. We should. So now let's continue and see what happens. Okay, so I'll say limit as x approaches infinity. The top prime is cosine 1 over x and times the inner function prime, which, remember, I said, please, I'm begging you, remember that this is negative 1 over x squared. Now, when I differentiate this, I get negative 3 halves times x to negative 3 halves minus 1, which will be negative 5 halves. Now I'm going to try to play with this. See what happens. Okay. So I have a negative 3 halves that it needs to be flipped, so I'll put it in front so I don't have to worry about it. It's a constant, it's multiplied. If it's addition, I cannot do that. But it's a multiplication, so I can flip it and get out of it. Get it out of here. Okay. Now, also, the negative with a negative will change into positive, and I'm finished with the signs. Cosine 1 over x, as x approaches infinity, this is 0, and then cosine, this whole thing will approach 1. So this is friendly. I'm going to leave it alone. Now, I'm going to focus on this. This is the key. Of course, everything is positive now. So the numerator is x to negative 2. Instead of 1 over x squared, I wrote x to negative 2. The denominator is x to negative 5 halves. For this piece, I copy the base and subtract from the power of the numerator, I subtract the power of the denominator. So this will be negative 4 plus 5, which is 1/2. So this is x to 1/2. So all I have left is the 2/3 in front, the limit as x approaches infinity, the cosine 1 over x, which is fine, and this is basically the square root of x. This approaches infinity, and this is nice and friendly. So the answer is infinity. Times 2/3, which is still infinity. This was an interesting problem.
Thanks for going through it.
But is it clear?
Yeah, the part at the beginning I need a little bit of help with the transforming it so it would give a
Yes. So you can
Yeah.
get to either 0 over 0 or infinity over infinity. That's the key. Because without this, I cannot continue with L'Hopital's rule. Yes. So you could have changed sign, but I think that route is more difficult. So you could have changed sine 1 over x into 1 over cosecant 1 over x, but you don't really want to differentiate that. So it's better to work on this and move it to the bottom. So always remember that x to negative 2, for example, is 1 over x squared. And also x to the second power, you can swap these two, you can get this. So this is what I used. I used x to 3 halves as being 1 over x to negative 3 halves. So in general, x to a equals 1 over x to negative a, or x to negative a equals 1 over x to a. So that was better. And look, it's intentional, of course. It was done wisely, not like this. No, this is not. This is torture. Okay, but this is interesting. This was done, with care. The problem was interesting. So it turns out that these come out to be something very nice. When I take the square root, it's infinity. If this were 0, I would be in trouble, but this is 1. So infinity times 1 times 2/3 is still infinity. Very good. Good question.